Hello, my name is Martin Zachariah. I'm going to be doing this problem. We're going to determine IXT in the circuit given that VST equals 6 cosine 5 times 10 to the 5th t volts. First thing we're going to do, since this is a steady state problem, I want to use phasors. So we have to convert this equation to a phasor. So what we do, VST equals 6 cosine 5 times 10 to the 5th t volts. It's going to turn into 6 angle 0 degrees. The next thing is we have to convert these capacitors. We have to find the impedance of this. So how to do that is this equation, 1 over JWC. W is going to be this number right here, 5 times 10 to the 5th. So we're going to do 1 over J times 5 times 10 to the 5th times 20 times 10 to the negative 6 equals negative J times 0.01 ohms. So we're going to do that. And then what we're going to do now is apply nodal analysis to this circuit and label all the nodes. So the first node is going to be V1. Second one, this is going to be VS. Third one is going to be V2. And then this one is going to be our ground node. Just label it V1, V2, VS equals 6 angle 0, and this is the ground. So let's now apply nodal analysis. So for the V1 node, it's going to be VS minus V1. So it's going to be 6 angle 0 minus V1 over negative J 0.1. It's going to be equal V1 minus V2 over 0.1 ohms plus V1 over 0.2 ohms. Now we're going to do node 2. Node 2 is going to be VS minus V2. So that's going to be 6 angle 0 minus V2 0.1 ohms plus V1 minus V2 over 0.01 ohms equal V2 over negative J 0.1. So what we're going to do, when the IX equation actually is going to be V1 minus V2 over 0.1 ohms. So what are you going to do now? If you have a TI Inspire, you're going to go to menu. You're going to go to algebra. You're going to go to the solve system of equations. And you're going to solve system of linear equations. And it's going to show up there, number of equations. It's going to be only 2 equations since you have 2 unknowns, V1 and V2. We know what VS is, so it's not going to be an unknown. So only 2 equations, X and Y. Press enter, and then you enter the equations. It's going to be, to type in your calculator, it's going to be x minus y, oh sorry, it's going to be 6 angle 0 minus x over negative j. But in the calculator, what you're going to do is you're going to find the pi symbol on your keyboard of the Inspire, and it's going to show a little I symbol, which that is what your j is. So you're going to go to the I, so it's going to be negative I, this is going to be I, times 0.1. And then equals x minus y over 0.1 plus x over 2. And you go to the next equation. You're going to go 6 angle 0 minus y over 0.1 plus x minus y over 0.1 equals y over negative I times 0.1. And then you're going to get, for the answer for V1, you're going to get 3.296 angle 15.94 degrees. And V2, you're going to get 4.12 angle negative 20.92 degrees. So when you plug that in to that XY equation, you're going to get Ix equals 3.296 angle 15.94 degrees minus 4.12 angle negative 20.92 degrees over 0.1 ohms. So that is going to come out to, you can just plug that into the calculator. It's going to come out to 24.71 angle 105.9498 degrees. Now plugging that back into like our original equation, Ixt will equal 24.71, we do amps, cosine, actually no, we'll do that at the end. I'm just going to put that at the end. Cosine 5 times 10 to the 5th t plus 105.9498 degrees minus 180 degrees. So then the final answer was going to be 24.71 cosine 5 times 10 to the 5th t minus 74.05 degrees amps. And that is how you find Ixt given that VST equals 6 cosine 5 times 10 to the 5th t volts using this equation. Thank you.